All right, let's go over some from Unit 11, Worksheet 2. I think I'll do the odds, but before I get started, and a lot of people will do this on the test, and they should do this on the test. So right up there at the top, sine squared plus cosine squared is 1. If I divide everybody by sine squared, I get 1 plus cotangent squared equals cosecant squared. And if I start up here and divide everybody by cosine, I get tangent squared plus 1 equals secant squared. So as we said earlier, you memorize the first one, the other two come from that one, and then if you're in that section of a test or worksheet or whatever, write those down. That way you don't have to think about them. You've got them to look at. All right, directions say simplify. So unlike yesterday's worksheet where we knew the answer, it was verify, it was just make it match. Here we don't know the answer. So we're just gonna we don't know the goal on this one, but it's really similar to worksheet 1. Let's see, cotangent is cosine over sine. Sine, I guess I could just leave as sine. The sines will cancel. And I got cosine. Well, that was an easy one. Number 3, tangent times cosecant. Well, tangent is sine over cosine. Cosecant is, let's see, he's partners with sine, 1 over sine. So the sines will cancel. That would give me 1 over cosine of x. And I guess that's not the most simple way to write that. 1 over cosine is the same as secant of x. This is a little bit tricky because is 1 over cosine correct? Yes, but is it best? Not really. And so most of the ones on the test will be verify. That way you'll know where you're headed. Because I really couldn't mark off if you got to 1 over cosine because that's the same as secant. Number 5. Cosecant squared minus cotangent squared over sine squared. So I'm looking back up. Cosecant minus cotangent squared. Oh, if I move that over, if I just move the cotangent over, then cosecant squared minus cotangent squared is 1. And 1 over sine squared would be cosecant squared. So if you know the Pythagorean identities, that was an easy one. Number 7. Secant minus 1. Well, that's not a Pythagorean identity because nothing's squared. So it's close to being, but it's not because it's not squared. So let's do algebra first. Let's FOIL this. So secant squared theta, and then minus secant plus secant will go away. Minus 1, and that looks like a Pythagorean identity, so I peek up toward the top, and if I move the 1 over, secant squared minus 1 is equal to tangent squared. Number 9. Well, this looks almost the same as number 7. In fact, I bet it's really close to number 7. So let's skip number 9 and do number 10 because that looks a little different. Sine of lambda, maybe never seen that before, but it's just a Greek symbol that means an angle, plus cotangent cosine. Probably the first bet is to rewrite cotangent in terms of sine and cosine. Cotangent is cosine over sine. Okay, that didn't help too much. But a cosine squared shows up. And if I really want to add these, I would need a common denominator. So I would need a denominator of sine, which means I need another sine at the top. So now I've got sine squared plus cosine squared. Whoops, that should ring bells. Whenever you say sine squared plus cosine squared, that you should recognize what that is right away. All over sine. Sine squared plus cosine squared is 1. And 1 over sine. Sine is reciprocal partners with cosecant. Yeah, so 1 over sine is equal to cosecant. Um, 11 and 12 look similar, so I'm going to switch back to 11 just to stick with the odds. Cosecant squared minus cotangent. Ooh. Okay, I'm going to need a Pythagorean identity to handle this, I think. Cosecant squared is 1 plus cotangent squared. So in place of cosecant squared, I'm going to put 1 plus cotangent squared. And then everything else stays the same. So if I kind of move things around a little bit, I get cotangent squared x minus cotangent x, and then 1 minus 3 would be negative 2. I don't know that it's abundantly clear what they want you to do from here, but that will factor. Right? If I view this as cotangent plus something and cotangent minus something, I need to get to 2, so factors would be 1 and 2, and if it's minus 2 and plus 1, that would get me to negative cotangent. Something real similar can happen on number 12. In fact, number 12 is just factoring. You don't need to do the Pythagorean identity. It's ready to factor. Number 13, use the Pythagorean identities to find sine of x for the given value of cosine of x. Well, sine and cosine and Pythagorean, sine squared plus cosine squared equals 1. So sine squared plus cosine squared is supposed to equal 1, and I'm trying to find sine. So sine squared plus 4/25 equals 1. Sine squared equals 1 minus 4/25. That would be 25 over 25. Need a common denominator. So 25, show my work, 25 over 25. 25 minus 4 is 21 over 25. So sine of x is equal to square root of 21 over 25. But when I put the square roots on, I have to remember to put the plus or minus on. It's not both, it's one or the other. And I will know which one it is based on this information. Between pi and 3 pi over 2, so that'd be over here somewhere. Well, the sign in the third quadrant is going down, so it's going to be negative. So that's why they gave me this information. It leads to whether this thing is positive or negative. 14 is pretty similar, so I think you can handle the rest of them.